In modern quantum physics, one of the most famous and confusing concepts is the idea of wave function collapse. We are often taught that the universe exists in a blur of possibilities, like Schrödinger's cat being both alive and dead until an observer looks at it. In that moment of observation, the math supposedly collapses, snapping the universe into a single, definite reality. It sounds like magic, suggesting that human consciousness somehow has the power to rewrite the laws of physics. But a growing number of physicists are arguing that this collapse is actually a total illusion. It is increasingly understood not as a fundamental event happening in nature, but as a limitation of our own perspective. At the quantum level, particles are described by wave functions. These aren't just abstract numbers, they are descriptions that encode every single possible state a system can occupy. According to the well-tested laws of physics, specifically the Schrödinger equation, these waves evolve smoothly and continuously. They don't jump, glitch, or break. So, where does the collapse come from? The modern view suggests that what appears to us as a sudden snap to reality arises simply because we are interacting with the system. The underlying wave dynamics actually remain completely intact. The wave never stopped. What changed was the information available to you, the observer. Think of it like a radio. Just because you tune into one specific frequency and hear one song, it doesn't mean the other radio stations cease to exist. They're still broadcasting, but your device can only process one stream of information at a time. Several leading interpretations of quantum mechanics, including decoherence and relational frameworks, suggest that reality does not select a single outcome universally. Instead, the physical interaction between you and the particle limits what you can access. From this view, the universe maintains its full spectrum of possibilities. It is a massive, branching structure of events, and a measurement is just you realizing which branch you are currently standing on. This perspective radically reframes what it means to be an observer. We aren't godlike figures who reshape reality just by looking at it. Instead, observation is a boundary of perception. The cosmos continues its seamless, wave-like unfolding, while human experience samples discrete, localized results shaped by context, scale, and interaction. We are seeing a slice of a much richer process. Quantum theory, in this light, points toward a universe that is continuous, coherent, and deeply relational. It tells us that the world is not random or broken, it is just much larger than what we can see. What we perceive depends not on a magical collapse, but on where and how we stand within the greater whole. Subscribe if you want to see the bigger picture.